As far as the SolidWorks is concerned, so I have already notified the Dean Academics, so I think it will be resolved now. So meanwhile, we'll continue with our theory part of this course. So in the previous class, we had started discussion on threaded fasteners, in which primarily we are discussing about screws and then nuts and bolts. So threaded fasteners, as we discussed earlier, are used to create temporary joints in components which need to be disassembled for various purposes. So we had seen the geometrical nomenclature of the threaded fasteners. We had seen the nomenclature, how to designate it on different machine drawings. So next we start with the this thing. I hope this was already covered in the previous one. So I'll go to the next slide, that is regarding the multi-start threads. So until now we have seen the fasteners, which in which the lead. So just recall the term lead and pitch. This is the point of discussion here. So we had discussed regarding lead and pitch. So lead is just to recall, it is the axial distance that you move or one can move upon completing one rotation on a fastener. So multi-start threads are basically used for a fast action. So in several applications or several equipment, it is needed that you quickly can tighten or untighten the screw. Very common example is the pen that you use. So in that case, also you need a very quite fast tightening and untightening. Beyond that, we have hydraulic valves and press and spindles. So in what happens in case of single start thread? So if you remember what is thread, so thread are basically helical grooves cut on the cylindrical surface. So these helical grooves which are cut on the cylindrical surface, they become the thread. So generally what happens in this case in single start thread, so there is one helix. Okay, this is just one helix on the surface of the cylinder. So this is, in this case, the lead, it is equal to the pitch. So what is pitch? Pitch is basically the distance between two consecutive uh, crests or two consecutive troughs. So but technically what is lead? So lead is also multiplied by another factor which is known as number of, this is number of starts. So just to increase the action or reduce the time of tightening and untightening, instead of one helix, I can cut here multiple helixes. So what I can do is I can cut multiple helixes here. But these helixes will also be passing through the surface. So what they'll do is that they give the lead, they increase the lead depending on what is the number of start. So suppose there is a two start or a double start thread. So then the pitch, the lead becomes 2 pitch. So it is 2 pitch for double start thread. And similarly, if you have 3, so then it becomes 3 pitch. So you can understand in case where we need a very quick action of tightening and untightening, there these multi-start threads are used. Now another way what could have been done to increase the pitch is in the single start thread. So you start to increase the pitch, then also the lead can increase. So how to increase the pitch? Now if I have the threads like this, so increasing the pitch means I need to basically reduce the diameter, reduce the core diameter. So now what is this? This is the core diameter. In case I am increasing the pitch, so the core diameter, what is going to happen? The core diameter is going to get reduced. So when the core diameter gets reduced, so what happens? The strength of the fastener reduces. So why we need strength? Strength is needed in order to sustain external loads which will be coming on the fastener in form of load of the component that is being fastened. So we generally don't increase the pitch too much, but we increase the number of starts. which increase the lead, and thereby giving a very quick tightening and untightening action. So these are multi-start threads. So what can be done? So generally the threads, they can be cut in the helices can be cut in an equiangular fashion. For example, if there is a two start thread, so they are 180-degree apart. I'll show in the next slide. And for three, it is 120-degree apart, and so on. So next, what we see is the schematic of this multi-start thread, which is in this one is basically the single start thread. The first schematic is the single start thread, where there is only one helix on the cylindrical surface. So lead becomes equal to pitch. In double start thread, there are two helices. One, they originate in diametrically opposite points, and lead, it becomes twice pitch. And this is a quadruple thread. So this, in this case, it is like lead is equal to 4 times pitch. So you can understand these type of threads can be quickly fastened and unfastened. Here what you see, it is an actual photograph of a multi-start thread. So you can see, you can actually count here the number of helices. So suppose this is the one helix being cut, this is the second helix being cut, and beyond at the back side there is the third helix being cut. So this can be this number can go to as high as 30 to 40 start threads. But again, the cost of producing such threaded fasteners is very high, and they are used in very specific industrial applications. But nevertheless, you should understand the need of these multi-start threads. So there is also a YouTube video link which you can explore later on. I will post the updated slides. So slides have been slightly changed, what is available in the Moodle. So in the updated slides, this YouTube link is also there, in which you can explore how these multi-start threads are produced using machining operation. Next, we come to the next variety of threads, in which we have the left hand threads and the right hand threads. So of course, we can understand this that when the threads are oriented in such a way that upon turning it clockwise, the nut, it advances towards the thread, so it becomes a right hand thread. And in left hand thread, so it advances away, it advances towards the nut when it is turned anti-clockwise. So if you remember the application of left hand and right hand threads, so we, in the PRT course, if you have done the PRT course, so you remember the gas welding, we discussed about gas welding process. So in the gas welding process, there were two cylinders, one for acetylene, one for oxygen. So in that, I mentioned that the threads on both the cylinders are opposite in nature. So that is one, to make it in the sense that one tightens in the clockwise fashion, another loosens up in the clockwise fashion. So that is just for the safety purpose, so that you accidentally don't open both the gases together, thereby leading to some hazard or accident. So that was an example in the PRT course, where we discussed in gas welding equipment, we have the threads on both the cylinders. One is the left hand thread, another is the right hand thread. So coming back to the machine drawing course now, left hand threads are designated as LH threads. So when we mention the designation, as we discussed in the previous class, so this we will mention as LH. So then it is understood this is a left hand type of thread. By default, all threads are right hand thread. If nothing is mentioned, so it is understood it is a right hand thread. But if LH is mentioned, so it is only specific mentioning for the left hand ones. So depending on applications, the required thread can be chosen. So this is just one application which I have mentioned, which one can, this is both different type of threads are used together. Next, I am coming to some more realistic applications of the threaded fasteners. So threaded fasteners, not only, as I mentioned, they not only hold two static pieces together, but yeah, they also are very useful in transmitting motion and torque. So this is an example of a coupler nut. I'm showing here a coupler nut. So where is this coupler nut? So this threaded portion you see here. It starts from here. Sorry, it starts from here and it ends here, and in between there is this turnbuckle. We call this as turnbuckle, which you can practically rotate just to tighten and untighten. And what is the schematics? This schematic is, it is a railway coupling which is used to connect bogies on a railway train. So these couplings, they are being hooked here. So this is the hook, okay. And then this, in this hook, basically we put this another linked hook, and then to tighten this up, we again use the fasteners, which are the externally threaded fasteners. And all this power transmission, it is going through these fasteners or the threaded joint. So this coupler nut is a very popular example used till date. It is not an obsolete, it is still used in practice in the railways. You can understand the load and speed at which the railways they operate, and in such conditions also these threaded fasteners are used. So coupler nut, it is an example of external threaded fastener used in the railways to transmit motion among different bogies. So in this case also, the one end of the this coupler nut, they have the left hand, the right hand thread. So there you have the right hand threads, and the other hand as the left hand thread. So this is again so that you don't accidentally untighten it. So in this case also, the combination of both the threads is used here. So this is beyond the welding process. And then length of the tie rod. So this tie rod is basically the rod which is connecting both of these. So this length can be adjusted based on how you tighten it or untighten. Next we come to the drawing part now, in which we'll see how we represent these threads on in drawing. Now we have seen that threads, they can take various shapes, as the V thread is there. Then we have the square thread is there. Of course, we have the buttress thread is there. We had discussed about this thread. Okay. Now this, if we try to draw this type of convention or the actual representation of the thread on a drawing, it becomes very cumbersome and it is very quite tedious. So that is why, to avoid this cumbersome task, or to ease out this task, what is being done, the threads are represented using a convention which is shown here. So like all the external threaded threads in the side view, or sorry, in the front view, are shown using this line, which indicates that this depth is taken by the threaded surface. So this depth is taken by the threaded surface. And of course, in the side view, you'll show the again, there are two concentric circles which show that the thread is being housed in between these. Again, just to avoid to avoid the confusion and simplicity, this is basically made in the only in the 3/4 quarters, not the complete. Similarly, in case of internal threads, so what is done here for internal threads, again, there are two parallel lines, and similarly, there are two concentric circles which are shown. And in the side view, they are represented as, if they are in the hidden portion, so then this type of parallel hidden lines are used as shown here. So again, these are not to be drawn. Perhaps much of the task is taken care by the CAD software. Manually, not much has to be done. But yeah, for reading the drawings, you should understand what these two lines are indicating if they are provided on any drawing. So these two lines, if parallel lines are there, the first indication what they are making is basically that this is an external threaded portion, or in case of such a component, they are showing the internal threads. And in assemblies, where basically what we do is to combine different components, what is done here. So again, there are two sets of lines which are overlapping. Okay, so two sets of line which are overlapping, they indicate that the threads are basically being coincided. So when you are tightening up any component in one component, the screw into any component, so the external threaded surface, they come in contact with the internal threaded surface, and the assembly is done. So in similar way, this is another way to represent thread, where you have these type of parallel lines and in which you have a thick line. So this is another way by which you can show the threads. So there are different options which you will be taught in the practical video. But for sake of the theory lecture, you should understand that threads are conventionally represented using parallel lines as shown here also, but we don't draw the actual representation of the thread because it is quite time taking. So these are well established, internationally accepted standards how threads are represented on a machine drawing. Next, we come to the assembly of these threaded fasteners. So the most common assembly with threaded fasteners are the bolted joints. So you look around yourself, you'll find a lot of bolted joints. So in which you have a bolt. So this what is passed in between, it is known as the bolt. And then what is coming on top of it is known as the nut. So just to represent this threaded joint or the fastener, so how this is done, you will represent the two parts. This is part number one. This is part number two, which are to be joined together using this fastener. Then the bolt head, it will come from the one side. So first you have to also show the hole. So hole has to be shown. So for showing the hole, basically what is done, you will take the use of this center line. So center line is used first. Then you will first take up the bolt part. So this is the bolt head here. And then the bolt body will come in between. And if you see all the bolts, they are not threaded on their full length. So only the threading is done from here to here. So that is why you have these parallel lines on both the sides. And then here what will come is the nut. So this type of nut will come here. And by drawing this convention, it is well understood that the threads of this bolt and nut, they will coincide together, and the two parts which are adjacent to each other. So the hatching pattern will be shown, since these are metallic parts. So hatching pattern will be shown, and the hatching will be done in a reverse manner to indicate that these are two different parts which are joined using this bolted joint. So I will now come to the various dimensions of this bolt and nut in the next slide, which you have to refer for drawing it in a given practical problem. So bolt and nut and bolt combination, these are one of the most popular ones we have already known. Now we already have studied about this, and it is used in combination as a fastening device. So bolt, it consists of a shank which is in a cylindrical form, and the cylindrical form will be basically containing the helix or the threads, which are external threads, of course. And the head of the bolt, it can be either a square or it can be hexagonal. So most commonly the hexagonal thread is used. So this is for the fact that whenever you are having a hexagonal thread or hexagonal bolt head, so in that case, while you are tightening it or holding it, especially you are giving a rotation to it, so generally short rotations are useful in tightening it up. So it is only 1/6 of the total required in case of hexagonal, while for a square head it is 1/4 rotation is required. And nuts are, they are also using made using either square or hexagon, whereas the hexagon is more preferred because these are tightened quickly, like in 1/6 of a turn they get tightened up very quickly. So what is shown here, these are basically the square nuts. Okay. Additionally, there is a washer here, which I will discuss in a while. What is the use of washer? So washer is also provided here in this joint. So these now we come to the various dimensions which are taken for hexagonal nut. So these are specifically for hexagonal nut. So again, these are empirical dimensions, which means these are derived using experience and all. So these empirical dimensions, they come, the base dimension that you need to know is the diameter of the bolt. And please note, this is the nominal diameter. So this is the same diameter which is present in this notation. So this 10, so this means if this is given, so this diameter of this becomes 10 millimeter. And then thickness of the nut is also equal to the diameter of the hole, or sorry, diameter of the bolt. And then width of the nut across flat surface, so it becomes 1.5 plus 3, 1.5 d plus 3 millimeters, and radius of the chamfer. So generally what you will observe that here the edges are rounded, so this rounding is done using 1.5 d. Again, in the practical video you will be explained how to make this, but as of for the theory part, you need to understand that empirical relations decide the various dimension of each nut. So this next are especially for the square nut. So in the exam or assignment, you can refer to these empirical correlations and draw the correct drawing. And all other things, as we discussed, this is the isometric view of the nut here, shown here. And here are basically the two views, the side view and the top view of the nut is being shown. So here what is done is that the radius of the chamfer and all these values are specified here. So these have to be taken to draw the drawing. Next are the bolt. So bolt, again, the dimension of the bolt will be the diameter of the hole is given. So based on that diameter of the hole, the dimension of the bolt is decided. So as shown here, the surface of the bolt is threaded, externally threaded. Similarly, it is done here. So this is a hexagonal headed bolt. This is a square headed bolt. And all other dimensions, they come in the proportion here of the diameter. So all this this can be taken into consideration while drawing of the bolt. So more clarity will be provided in the practical part. Next are the washers. These are also, they form a very important role in threaded joints. So washers, they look like this. This is an actual photograph of a washer. So first we need to understand what is the role of washer, why it is needed. So what is a washer? Washers generally they are made up of soft metals, or nowadays also made up of rubber or synthetic rubber. So this is a cylindrical piece generally made up of metal, and it is with a hole to receive the bolt. So the bolt will pass through it. So if this is it, so the bolt will pass through it first. Okay. So the use of washer is basically to provide perfect seating for the nut in order to distribute the tightening force uniformly. So whenever the bolt and nut they are tightened together, so to ensure, because the in close space joints, the nut may not completely spread the force, tightening force uniformly. So what is inserted in between is a washer. So here the nut in this case will come below here, and when you tighten it up, it will ensure the pressure is uniformly spread. And in many cases, it also prevents the surface under the joint to get damaged. It will prevent the damage on the surface. I'll go back to the slide of that rail joint here. So here what is done here, here you will see that a washer is being provided. So here also the washer is provided. So what is happening when you are tightening this nut here? So if the washer is not there, so this nut, when you give a full torque of tightening it up, it will start to come in contact with this plate, which is the joining plate here. And over the course of time, or over the course of tightening and untightening, what is going to happen that the nut will start eating into the plate, and that way the plate will get damaged. So to avoid that situation, we will introduce a washer in between, which will take up also, which will do two jobs for us. One is to distribute that force of tightening uniformly, and second job what it will do is basically to prevent the underlying surface from getting damaged because of the tightened fastener. So coming back to the washer, so these are the various dimensions of the washer as shown here. So again, D here basically stands for nominal diameter of the bolt. Diameter of the bolt. So again, this will be provided by the nomenclature, as provided in the nomenclature. So that D will be used. So this D plus 1 will be the internal diameter, which is 1 millimeter greater, and the outer diameter will be 2d plus 4, and the thickness of this washer is generally 1.15 into d. So all the dimensions are with respect to d. That is the nominal diameter of the bolt. Next, we are going to just oversee some more forms of bolts. So these include uh, bolts like eye bolts. So eye bolts are there, so which are used to lift heavy weight on crane hooks. So as shown here, here is this an electric motor. Okay, so electric motor has this type of a bolt being fixed on the top, and this can be tightened into. So these eye bolts, they can be tightened or they can be loosened into. But you see, to lift such a motor, which commercial or industrial motors are quite heavy. So this type of eye bolt is used. And in this eye bolt, what are the important parts? So in the eye bolt, why it is known as the eye bolt? So because you have this external surface or the external this cavity made here like this, so this forms the eye. So in the eye, what you can do, you can fix this hook, crane hook, and lift the heavy machinery like electric generators, motors, turbines. So the eye bolts, they can be screwed on the top surfaces. And for fitting an eye bolt, generally what is there? A tapped hole is there. So means a hole is provided here in which the internal threads are already made. So internal threads are there. So that means the hole is tapped. So if the hole is tapped, this means the internal threads are already there. So you just need to bring the eye bolt of the proper diameter and you can fasten it up. Now, other dimensions of the eye bolt, such as the this part below the eye, this sits, which on which the eye sits, this forms takes a dimension of 0.4d, and from this to the center of the eye is 2d. This is twice of the diameter, and below it extends 1.5d. Similarly, the internal radius is 1.5d, and then correspondingly other dimensions are mentioned here on the slide. So while making any eye bolt, the diameter will be provided. All other views have to be completed by calculating the dimensions using the empirical correlations as shown in this slide. Next are T-bolts with the square neck. So T-bolts, these are some other forms of bolt which may seem uncommon to you, but these are used very much in industry for different machine elements, especially on the T slots. So what are these T slots? So T slots are like this on the machine beds. So what we do is we create these type of slots on the machine beds in which are used to hold various fixtures, or you say various components or work pieces. So in that we use this type of bolt where you have this inverted T and you put in the bolt here. Okay, so these type of bolts are there, and various dimensions of the bolt are shown as shown in this slide. So these are also again threaded, so the part which is kept on the top can be fixed to it. Next come the studs, or we call it as stud bolt. So what is the difference between a stud and a bolt? So generally what is there in bolt, there is a separate bolt head which is used to tighten it and untighten it. But in case of stud, this is the actual photograph of a stud, which you see there are two ends which are threaded, and in between there is a plain part. So this plain part comes here, like as shown, which holds the two plates together. So here there is a main casting and a plate which are holding together using this stud. So in the main casting, there is a tapped hole in which the lower threads they'll tighten up, and then this plain part will come, and the top part of the stud will be then tightened up with the plate and will be locked using a nut. So we use a nut separately here to tighten it up. So where situations are there where you cannot accommodate a bolt head, so in such situations what we do, we try to use this stud. So you should know what is the difference between a stud and a bolt. Next, we have seen some nuts earlier. So we had seen two types of nuts. One are the hexagonal nuts, okay, which are the most common ones, and then we have the square nuts. But beyond these nuts, also there are several more. Although in this part I may not be covering every nut, but yeah, these are some of the photographs of some of the most popular nuts. So first is the slotted ring nut. So slotted ring nut is you have certain slots here, so they help in locking it up. Then is a flanged nut. So in this case, even if you have a small, relatively small diameter of the bolt, so this flange provided, which is fixed to the nut, it helps to tighten it up. Then is a cap nut. So these are not through nuts. So these are capped here. So you cannot just pass through a stud. So this won't be useful in that case. Then is a capstan nut, in which the tightening and untightening is done using by putting a, say, like a Tommy bar from these holes, and you can tighten it up or loosen it up. These are known as the capstan nuts. Then this is a wing nut. So because this has this shape of a wing, so you can understand by holding on the wing, you can apply torque to tighten it up. And since these are nuts, so they have the internal threads present. Then you have a castle nut. So castle nuts are very useful when basically we need to lock it up using certain pins. So we can insert a pin here in between and lock it up. I'll show some examples in the next few slides. So why it is known as castle? So the shape, this unique shape on the surface, this looks like a tower on a castle. So that's why this is known as, the name is given as the castle nut. And then you have knurled nut. So knurled nut, because you have this knurled surface here. So with the knurled surface, you can apply manually you can tighten it up or loosen it up. So these are known as the knurled nuts. We'll see some dimensional details of some of these nuts in the next slide. Uh, First is the flange nut. So you can correlate it with the flange nut is this one. So flange nut is shown here. So it is a hexagonal nut with a collar or a flange, which is provided here, and various dimensions are decided on D, so which is again the nominal diameter of the bolt. So the use of flange nut is there when the bolt is of relatively small size, or the size of the hole is slightly larger. Then cap nut, as shown in the previous slide, it has a closed end. Okay, so this is a hexagonal nut where the cylindrical cap is provided on the top, and this type of design, it prevents it from corrosion or leakage, very useful in plumbing. So how the question will be formed in the exam or assignment? So in the exam or assignment, you will be said that please to draw the views, the two views, that it is a front view and the top view of cap nut. For example, cap nut is given, and you will be given that diameter of the bolt which the nut has to accommodate is, say, 10 millimeters. So once this statement, you read this statement, so you will refer back to this drawing. Okay, and you will calculate all the dimensions based on the diameter equal to 10 millimeters. And once you know the diameter, you will start drawing the views based on the empirical dimensions as shown here. So that is how the things will go in the exam or assignment. Next, capstan nut. So capstan nut, as I already mentioned, this is it has the peripheral holes here, which are used for tightening it up. So these are used when you cannot accommodate the bolt head, and using a Tommy bar, you can tighten it up or untighten. So these are the two views. This is the side view and the top view, where you can see the holes, and you see again all the dimensions are with respect to D, that is the nominal diameter of the bolt. Next are the slotted or ring nut. So this was the first nut as shown here. This is the slotted and ring nut. Slotted and ring nut. This nut is in the form of a ring, not exactly a nut. And this is basically there are cuts being provided. So these cuts are used on larger screws, where this has a special spanner which can be accommodated in a minimal space. So the spanner, it basically engages in these gaps, and it can be quickly tightened and untightened. So again, all dimensions are presented here with respect to the diameter of the bolt which has to be made. And you can see the use of all conventional lines, like the center lines are there. Then the thread is shown using this parallel uh, concentric circle, not the complete circle, but it is in the 3/4 of the quadrant. And then in the side view, we can see the dotted lines which indicate these are the internal threaded surfaces. Then the wing nut, as shown in the photograph also, this has the certain wing shape here. So again, all dimensions are with respect to the diameter. And in the exam, the question will be like to draw a wing nut to accommodate a bolt of say 20 millimeters. So all dimensions will be calculated based on that. And this type of nut is used in applications where frequent tightening or untightening is required. For example, covers and lids of various machine elements. And the ease of this nut is it can be operated using the thumb. So using the thumb, you can tighten or untighten it. Next, we come to another important aspect with respect to threaded fastener is the locking arrangement. So locking arrangement is very important for the threaded fasteners, as in moving parts, especially where there are vibrations. So there may be a situation where the nuts, it may get loosened up. So if the nut becomes loose, so the integrity of the structure is compromised and it may lead to fatality or accident. So certain arrangements are done to lock this up that we are going to see now. So the necessity is we want the bolted joints to stay in their place without becoming loose. And often in moving parts, because of vibration, the bolted joints, they loosen up, and this may slacken the joint and may cause a serious breakdown. So different arrangements are there which are used to lock the bolted joints as shown in the slide. So the first arrangement here is the lock nut. So lock nut, it is an arrangement in which a second nut is provided. So first nut is there. This is, so here I am showing the what are the different parts. This is say the bolt, not the bolt, but yeah, we can say it is like a stud. So here not the bolt is there, but stud is there. So this stud is basically locked using this first nut one. Okay, nut number one, and then you introduce a lock nut here on top of it. So the lock nut, what it will do is here, what it will do is that it will also lock it up, thereby reducing the tendency of uh, this main nut to loosen up. And most of the times, what you will observe, these lock nuts are provided with this nylon insert. So this is black color here. This is the nylon insert. So if you remember in what category does nylon come? Nylon comes in the category of polymer. So nylon, it is a soft material with respect to this, say this is made up of chrome plated mild steel. Okay. So what this nylon does is whenever there are vibrations in the structure, so this since it is made up of polymer, so it is having that ability to absorb and dissipate the energy of those vibrations, thereby keeping the nut intact. So the movement of the nut is compromised or it is taken by compression of this nylon insert, thereby preventing the opening up of the bolted joint. So this is the one example how lock nuts are used. Next is by locking using a split pin. Now here the pin may be inserted at the cylindrical end using a this what is this? This is a castle nut, as we had discussed earlier. So you pass a pin in between here. So this type of pin will lock it up, or sometimes the pin may be also used on the other end. So in case of studs, you have a hole provided here. So you will insert a pin here. So pin will have a diameter of 0.2 D. So again, this D is basically the nominal diameter of the bolt. So the split pin is passed through this hole, and then the split pin is deliberately split up so that it locks it up. So you have to split so that you lock up, and this will prevent the bolt from coming out under the influence of vibration. So this is arrangement is known as the split pin arrangement. Next is basically the Willys lock nut. So this is a very special lock nut in which what you do is you have this type of a slot, and in the slot there is another fastener. So this another fastener, it is almost halfway. So it does not completely touch the machine part here, but it is halfway. So after tightening the nut, so the set screw is used on top of the nut. So thereby you compress the nut on the tightened say external bolt or so. So then you can see the various dimensions of this Willys lock nut provided here. And question is generally framed to draw a Willis lock nut, both the views of the Willis lock nut to accommodate a bolt of diameter, say 10 millimeters. So based on that, you will calculate all other dimensions and draw it up. So this is the actual photograph of the Willis lock nut. So in order to accommodate this secondary bolt, so again this surface has to be shown as the threaded portion. So that is why these parallel dotted dashed lines are present. Next is another arrangement to show the locking, that is using a set screw. So set screw, it is an external screw. So this is not integrated with the bolt or the nut. So it is an external screw which is fixed just, but the top surface of the screw is just touching this say nut. So when you tighten it up, so the since it is coming in physical contact with the nut, so it will avoid the opening it up because of the friction in between both. So it will minimize the chances of loosening this nut from top of this stud or the bolt. So this is known as the set screw arrangement to tighten up the or lock the nuts. So this is will minimize the tendency of loosening. So this threaded fastener, some aspects of threaded fasteners we have completed, and now I'll have some questions from you from the content which is covered today. So if there are any questions, so please feel free to ask. Yes.